this class, I will be differentiating tanX with respect to x from first principle. In my previous class, I have differentiated sinX and cosX with respect to x. If you have missed that video, link is there in the description. You can just go through. To start with differentiation of tanX, you should be knowing the one important formula which I'll be writing it now. That is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So let us start. So now I have considered a function f of x is equal to tan x. So what is differentiation? Differentiation is change in value. Now the value of x changes from x to x plus h. So I have got f of x and f of x plus h. So I'll just substitute in this formula. The next step is writing tan as sin by cos. I now have written tan as sin by cos and I have got this equation. So now I am going to take LCM here. LCM for what? Cos of x plus h and cos x. I have got the LCM as cos of x plus h into cos x. So the next very important and a little bit confusing step. So I'll just tell you what to do now. Now after taking LCM, just divide this LCM by this denominator and whatever the value you get, just multiply it to the numerator. I'll do it and I'll explain it again. If you carefully observe, the LCM is cos of x plus h into cos x. Firstly, I have divided this LCM by cos of x plus h. What is the value I have remaining? Cos x. I am going to multiply that with the numerator. What is numerator? Sin of x plus h into cos x. Minus, again divide this denominator cos of x plus h into cos x by this cos x. What is remaining? Cos of x plus h. Multiply with the numerator. What I will get? Cos of x plus h into sin x. So now one more thing, if you carefully observe the above numerator equation, sin of x plus h into cos x minus cos of x plus h into sin x. If I consider this x plus h as a and x as b, just read out the numerator again, sin a cos b minus cos a sin b. So it is in the form of sin of a minus b. I have taken the complete numerator now as sin of a minus b. The value of a is x plus h and the value of b is x a minus b. Now simply I can cancel this plus x and minus x. What is remaining now? If you carefully observe again, sin h divided by h. Sin h by divided by h. We know that the equation sin theta by theta is equal to 1. That we have used this both in sin x and cos x with respect to x when differentiated it. So it's the same thing now. The value of sin h by h will become 1. And one more thing, in the next step I'm going to apply the limits. Applying the limits in the sense, the value of h in the equation will be 0. The limit h tends to 0. I have considered this sin h by h as 1 and I have applied limits and where h has tends to 0. What is remaining now? 1 divided by cos of x plus 0 into cos x. X plus 0 is cos x itself. Cos x into cos x is cos square x. What is 1 by cos x now? We know that 1 by cos x is secant x. So 1 by cos square x will also become secant square x. Finally, we have come to the conclusion. What is the differentiation of tan x? It is secant square x. I hope you have understood. Thank you. Stay tuned.